Negative exponents. So if n is a counting number and x is non-zero, then x to the power of negative n. The equivalent is to say 1 over x to the positive n. Or 1 over x to the negative n is equivalent to saying x to the positive n. So in few words, to simplify, find its reciprocal and change the sign of the exponent. So do notice, on the left side, x to the negative n. It has a negative exponent. You put underneath a fraction sign, and that makes it a positive exponent. On the right side, if it's under the denominator with a negative exponent, to convert to a positive exponent, bring it to the top, in other words, to the numerator area. So let's try some examples. This is random examples that I came up with for you. Example number 1, for the first case scenario. If we have, for instance, 3 times k to the negative 3. Do notice, does the 3 have an exponent? No, in this case it doesn't. But the k has an exponent. K has an exponent of negative 3. To convert to a positive exponent, we've got to put it under the denominator. In other words, let's put a fraction sign and put it underneath. So 3 over k to the positive 3 makes it a positive exponent. And essentially, that's as far as we can simplify it. That's our answer for that one. Second case scenario example. Example number 2. If we have, for instance, 11 over 10 times k to the negative 3. Well, 11 has a positive exponent. 10 has a positive exponent. The one with the negative exponent is the negative 3. Well, and that negative 3 belongs to the k, right? So it means the k has a negative exponent. So raising it up to the top makes it a positive exponent. Do notice the 11 still at the same spot. The 10 still at the bottom. The only one that changed was the k with the negative exponent went to the top and it became a positive exponent. And that would essentially become our final solution. We can't simplify any further since 11 is a prime number and 10 is not a multiple of 11, right?